Visual Sonics is the world leader in real-time, in vivo, high-resolution microimaging systems, providing modalities specifically designed for preclinical research. You can now listen to the light with photoacoustic imaging offered by the new Vevo LAZR system. In this video, you'll be introduced to the Vevo LAZR photoacoustic imaging system and its components. We'll show you the principles of photoacoustic imaging and also go over two application areas where photoacoustics is being used today, namely for quantification of hypoxia via oxygen saturation, sentinel lymph node detection, and also the latest methodology for imaging and quantifying nanoparticles in vivo and in real time. Photoacoustics refers to the generation of ultrasound using light. Nanosecond pulses of light are emitted by high-frequency laser light source and illuminate the tissue of interest. The tissue absorbs light at the specific wavelength being used, resulting in minute local heating and expansion of the tissue, which is detected as an ultrasound signal. Let's take a look at the components of the system. The Vevo LAZR photoacoustic imaging system consists of the digital imaging platform, including the laser cart. The laser-tight imaging enclosure is a laser light containment and animal handling and positioning system. It houses the intricate rail system, 3D motor, linear array transducer, micro-injection system, physiological monitoring system, and integrated anesthesia for superior animal handling and study reproducibility. Furthermore, containment of the laser light is achieved with extensive interlock circuitry, an essential requirement for operator safety and particularly important for shared use facilities. The integrated fiber optic linear array transducer generates the images and contains 265 elements for ultrasound detection and a light source for emitting laser pulses. Imaging oxygen saturation is one of the key functionalities of the Vevo LAZR photoacoustic system. The Vevo LAZR is capable of measuring oxygen saturation within the tissue based on the differential absorption spectra of the oxygenated and deoxygenated blood. This rendering shows hypoxic regions in a mouse hind limb tumor in blue, as well as a highly vascularized and therefore oxygenated regions in red. The scale in millimeters on the right indicates the size of the tumor. Furthermore, the animal's physiology is displayed on the bottom of the screen with the ECG cycle in green and the respiration rate in yellow. The ability to measure oxygen saturation is also important in diabetic and stroke animal models. In this experiment, a tourniquet was applied to the mouse hind limb to induce ischemia. Upon tightening of the thread, a visible reduction in oxygenation occurs in the distal portion of the hind limb, where we can see the signal changing from red to blue, indicating a decrease in oxygen saturation levels. The Vevo LAZR is capable of 3D imaging of internal tissues, permitting the user to gain greater insight into regions of interest. Here is the ischemic hind limb tissue shown in a 3D configuration. Notice the heavily deoxygenated distal portion of the hind limb illustrated in blue. In addition to oxygen saturation, photoacoustic technology is able to detect the endogenous heme signal, making hemoglobin identification in a tissue simple and quick. The effect is shown here in a rat hind limb tumor, indicating areas of blood flow and vascularity. The Vevo LAZR is designed to work in concert with contrast agents such as nanoparticles and optically absorbing dyes. In this experiment, a bolus of methylene blue dye was injected into a mouse forepaw, revealing the sentinel lymph vessel as illustrated in red. This feature holds important oncology diagnostic capabilities since it's the first vessel to receive metastatic cell drainage. Nanoparticle delivery serves as an additional tool for contrast enhancement and targeted imaging with the Vevo LAZR. Here, a bolus of untargeted gold nanorods are delivered intravenously into the mouse and accumulate naturally at the tumor site. This is evident by the increase in red signal and enhances the endogenous heme contrast offered by photoacoustic technology. The signal is detected at 800 nanometers. Anatomical and photoacoustic images are co-registered and can be viewed as an overlay or side by side, as shown in this example. Pre- and post-gold nanorod infusion can also be captured in 3D, as shown here. The Vevo LAZR photoacoustic imaging system is a revolutionary tool for in vivo research and additionally benefits from the extensively validated technology of the Vevo family of high-resolution micro-ultrasound products. With more than a decade of experience devoted to preclinical imaging resulting in over 700 installations and thousands of users worldwide, Visual Sonics has established relationships with an extensive network of researchers. Visual Sonics has a focused scientific applications team and dedicated technical support and product teams to support the demands of cutting-edge research. To find out more about our recent advancements and how photoacoustic technology employed by Vevo LAZR can benefit your research ambitions, please visit our website or contact us. The future of in vivo imaging is here.